This is round 2 of mastering derivatives. You really should already know your derivative rules. You're just trying to practice them. And so to use this video, you're going to hit pause every time a new page comes up. You're going to write down what you think the derivative is. Then you're going to hit play to advance the slide and see the actual derivative. It's really important that you write it down because that's that translation from your brain to paper that you're practicing. The directions: find the derivative of each of the following functions. This is a function of f of x equals some number raised to a function of x. So this a is just a number. And what you get is the natural log of the base times keep the function exactly the way it is, and then chain rule out the derivative of what is in the exponent. You can put parentheses around this. Either way is correct. Next. Yes, you want to take this second term and make this exponent negative, bring it up into the numerator. And now we can just use the power rule. Negative 3 times 2, negative 6x to the negative 4, positive 3x to the negative 4. Next. You're going to use the extended power rule or chain rule on this one. Bring the 7 down. You get negative 14. Keep exactly what's inside and subtract 1 from the old exponent. So 7 minus 1 is 6. And then you chain rule out the derivative of what's inside. Derivative of x, 1. Derivative of negative 3x to the 4th, negative 12x cubed. Next. You have to rewrite this guy, take this square root and make that exponential form. Now we're going to go ahead and take the 1/2 and bring it down out front. 1/2 times negative 3 is negative 3/2. Keep exactly what's inside, subtract 1 from the exponent to get negative 1/2, and then chain rule out the derivative of what's inside. From this term, you get 10x to the 4th. From this one, you get negative 3. Derivative of a constant is 0. And so you're done. Next. This 4 in front is just a coefficient, and so it comes along for the ride. The rest of this is the derivative of what's in parentheses here. Natural log of the base. Keep the original function exactly as is. Chain rule out the derivative of the exponent. Derivative of negative x, negative 1. Derivative of this term, 4x cubed. Next. You do have a product of two functions here. And so you're going to use the product rule, P and Q, where the derivative is equal to the derivative of the first term times the second, plus the first times the derivative of the second. And so when you do that, derivative of the first, e to the negative 2x, chain rule out the derivative of the exponent. Second guy comes along for the ride. Plus sign, first comes along for the ride. All of this is the derivative of q. Natural log of the base. Keep the function exactly the way that you saw it. Chain rule out the derivative of the exponent. Next. For this one, again, see that? Yep, let's take care of that. We're going to change that to exponential form. And you do have a product rule again. We can't combine these, so we have P and Q. We are going to do the derivative of the first, 3x squared, times the second, plus the first times the derivative of the second. All of this is the derivative of the second. The 1/2 comes down. Keep what you have. Subtract 1 from the exponent to get negative 1/2. And then chain roll out to get that negative 1. By the way, these exponents are riding pretty low. We love them to be up here, but for this program, it won't ride them really high. So they look kind of weird like that. Next one. Product of two functions. 1, 2, going to have to take care of that root and put it in exponential form. And then we get derivative of the first, rewrite it, chain rule out the exponent, keep the second, plus sign, first times the derivative of the second. All of this is derivative of the second. Bring the 1/2 down. Keep what's inside. Subtract 1 from 1/2 to get negative 1/2. Chain rule out the derivative. So you get 0 from the 1, negative 6x squared from the second. Last one. Yep, it's a quotient rule, and we can't do anything with this. This is P over Q. So the derivative is going to be derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. So take the derivative of P, that's the numerator, keep it like it is, chain rule out the negative 5, denominator comes along for the ride, minus the numerator as he is, derivative of the denominator, 2x from this guy, 0 from him, so 2x, all over the denominator squared. And that's it. Remember, we just leave these like this. Typically, when we take derivatives, we're looking for slopes of the function to get a tangent line or an instantaneous rate of change at a particular x. So you leave it like this and then substitute in your x value. That's it. Hope you're having a great day.